Today we're going to review solving quadratics, and we're going to kind of think through everything. Just remember at the top of your, in everything that we do with solving quadratics, the number one thing we always want to remember is we are finding these x-intercepts. We are finding where they cross this axis. So it really keeps us in a good mindset. Now, in this first one, it's asking which method can we definitely not use to solve this. So we just want to go through the different options. Factoring, can we use factoring? Well, can I think of anything that will multiply together to give me 24 and add together to give me 10? Well, yeah, 6 and 4 would work. So I can definitely use factoring. Can I use the quadratic formula? Yes, because you can use the quadratic formula every single time because we had that very long equation that was on the right side of the board where I have all the symbols and I solve for every single quadratic, so that one always works. Square roots. Well, to solve with square roots, we only need one x. And here we have two x's because we have an x here and an x here. So C is the correct answer. And we can solve this by completing the square because we could add over the 24. You can cut 10 in half and make everything work out nice. Okay, let's look at number 2. Which number goes in the blank to accurately complete the square? Well, when I'm looking at this, I want to figure out what I should put here and what I should put here. To do that, you got to cut 8 in half, which half of 8 is 4, and then you got to square that. So when you square that, you get 16. So we should put 16 in each of these blanks. And then you could, if you complete the square, you could actually see that that would factor nice. And then how many solutions does this quadratic have? Well, this quadratic, for one thing, can't have infinitely many solutions because it can't cross this axis infinitely many times. So we know D is gone. And we're basically trying to figure out, does it do this? Does it do that, where it hits once? Or does it cross twice like we had up there? To do this, we are actually going to use the quadratic formula, but not the whole thing. Because when you look at the quadratic formula, whoops, if I could write today. The part that stops things from working out is the square root part. So we are actually just going to worry about the square root part. I'll write the rest in, but we'll kind of stop early. So we would have 6 plus or minus the square root of 36 minus 4 times 1 times 9 all over 2. Now again, I really don't care about this outside stuff. I care about what's going to happen inside the square root. And when we do that, we would find that we would get 6 plus or minus the square root of 36 minus 36, because 4 times 9 is 36, all over 2. And 36 minus 36 is 0. So we would have 6 plus the square root of 0 over 2. Well, you might go, well, we have two answers because we have that plus or minus. But in this case, we would only have one solution. And you could double check this. You could go, oh, what's 6 plus 0? 6. What's 6 minus 0? 6. So your answer to this would be 3 or 3. So for this thing, we are actually only going to get one solution. Let's try the next one. Okay, so now we're going to look at number 4. And the first thing you want to do for all these problems is decide which method you're going to use to solve them. Well, the first one we have is square rooting. And we know that's not going to work because we have two x's. This only works for one x, so that one's gone. The next thing we should try to do is factor. So we have to think what multiplies together to give us 3 and adds together to give us 8. Well, there's nothing that does that, so that one's gone. The next one we want to try to do is complete the square. So when I try to complete the square on this thing, I need to see if it has a number in front of its x squared, which it doesn't, so this is a promising thing, and I need to see if this is even. And this is. So both these things fit the requirement. So we're actually going to end up using completing the square. The first thing that we want to do when we complete the square is completing the square means that we're going to force this thing to factor. So it won't factor right now, so we're going to force that to happen. So this positive 3, we're going to subtract 3 on both sides to get rid of it. Now of x squared plus 8x equals negative 3. Now we're missing a term, so we're going to be able to plug in a term to force it to factor. So the term that we're going to plug in will be 16, because we'll half 8, which will give us 4, and then square that, and that will give us 16. And then if you add it to one side, you have to add it to the other side. This will give us, well, now we can actually factor this side. So this will give us x plus 4 and x plus 4, because 4 times 4 gives me 16, and 4 plus 4 gives me 8. And then this side would be 13. Now what's faster than writing x plus 4 times x plus 4 is x plus 4 squared. And this would be equal to 13. And then we'll take the square root of both sides. When I take the square root of this left side, I'm going to get this as x plus 4. And then I don't know what the square root of 13 is, but I'm sure we can find it out really quickly. So I'm just going to pull out my calculator and take that square root. That'd give me 3.6. Whoops. And x plus 4 equals negative 3.6. If you have a positive of something, you also have to have a negative, because square roots produce 2 answers. I'm then going to subtract 4 from both sides. That's going to give me negative 0.4. And here, when I subtract 4 from both sides, that's going to give me x is equal to negative 7.6. So those would be my 2 answers. On those square roots, you can just round to the nearest tenths place, just because those things go on forever and they're really not the best to try to find exactly what it is. Let's try the next problem. We're going to go to the same checklist we did before. We can't use square rooting because it has 2 x's. Now we check factoring, and we got to check if anything multiplies together to give us 12 and adds together to give us 8. So let's think of what multiplies together to give us 12. Well, we have 3 and 4, which that'd give us 7, so that doesn't work. We'd have 6 and 2. Well, that will give us 8. So now we just have to think about how we get negative 8. Well, if this was a negative 6, and this was a negative 2, that should work out. And then we want to make these things equal to 0. So my final answers would be 6, because 6 makes this side equal to 0, and 2, because 2 makes that side equal to 0. Then I'm done. So the whole point is try square rooting. If that doesn't work, then you try factoring. Let's try the next thing. Most of the time we need these things equal to 0. This time we won't, because the first thing that we always look at is, does it have 1x? And it does. So this time we can finally use square rooting. So we're just going to solve this like normal. So I'm going to subtract 55 from both sides. When I subtract 55 from both sides, I'm going to get 2x squared equals negative 50. Then I'm going to divide each side by 2. That's going to give me x squared equals negative 25. And now my final step is always take the square root of both sides. Now the issue with this is you can't take the square root of negative 25. If you try to throw that in your calculator, you get this syntax error. So we're going to say that is no solution. Okay? And that just means that our quadratic started above the axis and will never hit it. So that's okay. It happens sometimes. But that would be a no solution example. Let's try the next one. Okay, so now we're going to check this next problem. And so first we know we can't use square rooting because it has 2 x's. Next thing we know, we can't factor, or we should try to factor this. So is there anything that multiplies together to give me negative 30 and adds together to give me 10? Well, I don't think so, but we can try a couple things. 30 is made up of 2 and 15, so that gives us close because that would give us 13. And the next would be 3 and 10, and it doesn't look like we can make 30 equal 10. So if we can't do that, we're going to solve this by completing the square. So again, since it won't factor, we'll force it to factor, so we'll add 30 to both sides. We'll get x squared plus 10x equals 30. We then need to find what's going to replace this right here. So we'll cut the 10 in half and then square it, and so that will give us 25. And then we'll add 25 to the other side. Then I'm going to factor this side, so I'm going to get x plus 5 and x plus 5, and that's going to equal 55. And then if things are the same, what's faster than writing that is x plus 5 squared equals 55. Then we'll take the square root of both sides, and when we do that, we're going to get x plus 5 equals, and then I don't know what 55 is off the top of my head, so again we'll take out the old trusty calculator, take the square root of 55, so that's 7.4 about. So we're going to get 7.4, and this other side will be our negative 7.4. So then I'm going to subtract 5 from each side, and we will get our final answer to be x equals 2.4 and x equals negative 12.4. And those are our two answers. Let's try the next one. Okay, so we have a proportion. So anytime we see a proportion, we have to cross multiply. So we're going to multiply here, multiply here. So when I multiply the x's, I'm going to get x plus 4 times x plus 2. And then when we do 3 times 5, we're going to get 15. What I'm going to do from here is I'm going to distribute to kind of see what I get. And so I'm going to get x squared plus 2x plus 4x plus 8. That's going to equal 15 on this side. And then we just got that by just multiplying the x's over. So x times x is x squared, x times 2 is 2x, 4 times x is 4x, and then 4 times 2 is 8. We can combine those two middle things. So we get x squared plus 6x plus 8 equals 15. And you'll notice this side equals 15 and it doesn't equal 0. So that's the first thing we're going to fix. We're just going to subtract 15 from both sides. And we're going to get x squared plus 6x minus 7 equals 0. And this is the stage where we try to pick a method. And again, we can't solve by square rooting because we have two x's. So then we go to our next step, and our next step would be factoring. And I think this thing does factor because if you choose positive 7 and negative 1, you can multiply together to get negative 7 and add together to get positive 6. And then our final step would be making these things equal 0. So negative 7 would work there, and positive 1 would work for this side. And that would be my final answer. We'll try the last problem out of this set of choosing the methods, but just make sure every time we choose the methods we go in the same order. You do square rooting, then factoring, then completing the square, then quadratic formula. Okay, so let's try the last one. Okay, so I can't use square rooting because I have two x's. I can't factor this because it has a number in front. I'm not going to use the completing the square because it's got a number in front. So I'm going to use the quadratic formula. You'll notice that this doesn't equal 0, so we can only use the quadratic formula if this thing equals 0. So what we're going to have to do is we're going to have to subtract the 3 from both sides so that we can get this side equals 0. And then we're going to use the quadratic formula to plug everything in. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we're just going to plug everything into that. So instead of writing negative b, we're going to write 7. And then it's plus or minus the square root. And then b squared would be 49 minus 4 times a, which is 2, times c, which is negative 3. And that's all over 2a. So 2 times 2 would be 4. Now from this stage, I would like to know what's underneath that square root. So what I'm going to do is I'm going to plug all this that's underneath my square root into my calculator. So that would be 49 minus 4 times 2 times negative 3. And that's going to give me 73. So I'm going to say equals 7 plus or minus the square root of 73 over 4. And then, because we know that that is the square root of 73, like that's not a nice number, I'm going to again throw that in my calculator and see what I get, which will give me 8.5. See how this has plus or minus? You can't do plus or minus at the same time. So now, this is the stage where we're going to end up splitting this into two separate problems. So I'm going to say that this is 7 plus 8.5 over 4 and 7 minus 8.5 over 4. Well, 7 plus 8.5 would be 15.5. So again, you won't always want to add the top first and get that answer, and then divide it by the bottom. So that's around 3.9, or we could even write it if we wanted to, 3.875 is one of my answers. So let's find the other one. That'd be 7 minus 8.5, which is negative 1.5, and then divide that by 4, and that would be negative 0.375. Okay, and those would be my two answers. So make sure when you do the quadratic formula, the first step is always plug everything in, and then if you noticed, after we plugged everything in, I always put what's underneath this square root in my calculator and see what my discriminant is, and then I will use that to find my other two things. Let's try the last couple problems. So draw a quadratic equation that has no solutions. Well, that should be pretty easy because that just means it doesn't hit the x-axis. So we could draw a U-shape that's up here, or we could draw a U-shape down there. Doesn't matter. Drawing a quadratic that has no solutions should be very, very easy because you just have to make sure it doesn't hit this axis. Give a completing the square problem that would be difficult to solve. So difficult to solve doesn't mean we wouldn't solve it with completing the square. So difficult to solve doesn't mean like some people go, oh, I just won't write a quadratic. Well, that won't work because we need to still be able to solve it. So something I think that would be difficult to solve would be something that looks like this. And this would be difficult to solve because of that b term. So the problem is that b term, because you would have to cut 5 in half, which would give you 2.5, and then you'd have to square that, which would give you 6.25, and adding that to both sides is tough because it's a decimal with a decimal. Another one that you could use would be like x squared plus 9x plus 4, because this, like if you cut 9 in half, that's 4.5, and then I don't know what 4.5 squared is. I would have to use my calculator and just kind of see what that would give me, and that's 20.25. So you can see, like, if you make it odd numbers, that becomes harder and harder to do because of that middle number being the way it is. So just remember, like, you do not want to solve completing the square problems when this middle thing is an odd number. Let's do the last problem. Okay, so we have to find when this rocket that's being launched will hit the ground. And again, the context of this problem isn't as important. They tell you the hill is 80 feet up above the lake, and they say it will reach a maximum height and then explode, and then the rocket, I guess the remains of the rocket will come back and hit the ground. So we're going to look for when that rocket that has gone up in the air will come back and hit the ground. So it's going to do one of these. Whoops. It's going to do one of these, and we're looking for that point right there. So another name for that point would be an x-intercept. And so because that's an x-intercept, we need to solve this. So this is our quadratic equation. So that quadratic equation, when I look at that, I'm going to use quadratic formula because it's got a number in front of it, x squared, or in this case t squared. So when we use the quadratic formula, we're going to use negative b, which would be negative 64, plus or minus the square root of 64 squared minus 4 times a, which is negative 16, times c, which is 80, all over 2a, and 2 times negative 16 would be negative 32. We're then going to plug that in our calculator. So 64 squared minus 4 times negative 16 times 80. That's a big number underneath our square root, but that's okay. So we'll have negative 64 plus or minus the square root over negative 32. And I just forget what that number is, so I'm going to bring that back up on my calculator. 9216. Let's take that square root and see what two numbers we get. So when I take the square root of 9216, I get 96. Oh, that's a nice number. So then we're going to have negative 64 plus, and what did we get? I already forgot. 96, okay. So 96 over negative 32, and negative 64 minus 96 over 32. Now when I do this, I don't really have to do this side, and I'll show you why in a second, because we would do negative 64 plus 96, and then divide that by negative 32, and you'd see you'd get negative 1 seconds. Can time be negative? No, so that one doesn't work. So then we would just do the other one, which would be negative 64 minus 96 divided by negative 32. And that would give us 5. And I forgot to put my negative sign there, but that's okay. So this would be our answer. It would take 5 seconds for it to hit the ground. So make sure when you're doing all these things, you just keep in mind which method am I doing, why am I doing that method, and then how you'd solve it with that method. If you have any trouble, let me know.